Before Thanksgiving, I want you to fully understand two concepts. Number one is vector addition, and number two is friction. Vector addition we'll do on Monday, and friction we'll do on Tuesday. Vector addition, I'm going to go over this problem right now so that you can come to class on Monday with at least 20% understanding. Some of you, of course, will come to class with more than 20% understanding. That's good, but try to come to class with more than 0% understanding so that you can understand the concept really well on Monday. So vector addition, I have x-axis and I have y-axis, and I have a vector, let's call A, 30 degree above the x-axis, and let's say the magnitude is 3, and I have vector B, which is 90 degree above the x-axis, which let's also give it the same magnitude 3. So what we're going to learn is how to add vectors. You already know how to add scalars. The adding scalar would be 3 plus 3 is equal to 6, but that would be wrong because these are not scalars, because I already put a arrow on the top of the vector A and on the top of vector B, and you already know the differences between scalar and vectors. A plus B would be 3 meter plus 3 meter would be 5.2 meters. And you're going to learn how to do this 5 different ways. Number 1, trigonometry. Number 2, geometry. Number 3, law of sine. Number 4, law of cosine. And then distance formula. So vector A is 3 meter, which is 30 degree above the ground, and vector B is also 3 meter, which is 90 degree above the ground. What I want you to do, I want you to find the displacement vector. Okay, displacement vector has two things: resultant and the direction. I want you to give me theta in terms of theta. Okay, all right, so first I'm going to show you how to do it by using trigonometry. All right, so let's do it by trigonometry. So I have two vector. Let's start from right here. So I have two vector. Vector A, which is green, so I'm going to use green, vector A. Vector A has two components, x and y, and x is 3 cosine 30 degree. Remember, x is cosine, y is sine, don't forget that. And then 3 sine 30 degree, 3 cosine 30 degree is 2.6, 3 sine 30 degree is 1.5. Now the vector B is blue, so let's use blue. So vector B, x and y, 3 cosine 90 degree. Understand that this blue vector is 90 degree with respect to the x-axis. All right, so 3 sine 90 degree, so this is 0 and this is 3. You probably think how I got them. Very easy. If you put it in calculator, then cosine 30 degree would be 0.87, sine 30 degree would be 0.5, cosine 90 degree would be 0, and sine 90 degree would be 1. Okay, so this is how I got them. X is what? 2.6. And now you have to do y. Y is 3 plus 1.5, y is 4.5. Okay, now I want to find the displacement vector. I want to find the resultant, so let's find the resultant. So the resultant is 2.6 square plus 4.5 square, so resultant is 5.2. okay, so the resultant is, I can erase this one because you already know what does that mean, 5.2 meter. Now I have to find the direction. Okay, now let's find the direction. How can I do that? Very simple. Let's erase this so we have the room. Let's draw this over here, x and y. All right, so let's draw the vector b first. All right, now we're going to use something called head and tail. What do I mean when I say head and tail? So we're going to be discussing head and tail method. Head and tail. All right, so this is a vector. This vector has a tail, and this vector also has a head. So head and tail going to allow me to show you the angle in a very friendly way. So I have to find the head of vector b. All right, so I find the head of vector b. This is the head of vector b. Now I have to find the tail of vector a. All right, the tail of vector a is obvious, so I'm going to place the tail of vector a at the head of vector b. Now I have to move the vector a, place the tail of vector a at the head of vector b without changing the direction. So now if I draw it like this, I change the direction because this is 0 degree with respect to the imaginary x-axis. So this is not good. So I cannot change the direction. So this is now similar to this one. Why is that? Because if you have imaginary x-axis, then if you have imaginary x-axis, this is 30 degree and this is also 30 degree. Okay, good. So I have vector a and I have vector b. I have vector a and I have vector b. Now I know the resultant, but I have to draw the resultant. So how do you draw the resultant? From the origin to the arrow at the end. This is how you draw the resultant. So let's draw the resultant. This is the resultant. What is the size of the resultant? 5.2. Now we're going to find the angle. All right, let's see whether we can find the angle. Angle, we're going to use the trigonometry, and trigonometry, angle always tangent theta is y over x. So then theta is tangent inverse, what is y? Y is 4.5. What is x? 2.6. All right, so theta is 60 degree. So this angle is 60 degree. All right, this is how you find it. Okay, good. Now let me do now geometry. Okay, now I'm going to do the same problem using geometry. All right, so now this time we're going to use geometry. All right, so geometry would be pretty simple. All right, so what are you going to do? Let's draw this thing, x-axis and y-axis. No, I need more space, so I'm going to move it over here. So x-axis and y-axis. All right, so now let's draw the blue vector, which is vector b, and vector b is 3, as you know that. Now I'm going to rotate the green vector, all right, by using head and tail. So this is the head and tail. This is the head and tail. Allow me to rotate it without changing the direction. Okay, so this is vector a. Vector a, you notice, has something, x-axis and y-axis, x and y. All right. x and y. All right. So how do I know how much is the x and how much is the y? Well, pretty simple. This is 3, we know that, and this is 3, so let's write 3 over here. Let's write 3 over here. So this is 3, and this is 30 degree. Why is that 30 degree? Because this is 30 degree, so this must be 30 degree. If this is 30 degree, then this is 60 degree. So what I have over here is basically opposite to 90 is 2x, opposite to 30 is x, opposite to 60 x root 3. If I so what is 2x? 2x is 3, so x is 1.5, so x is 1.5, so 1.5 root 3 is 2.6. so it seems like the red one is 2.6 and yellow one is 1.5. all right, so 2.6 and 1.5, good. Now how that's supposed to help me find it? Okay, that this yellow one I can move it over here. All right, so I'm going to write 1.5. so this yellow and then blue, they are same direction, so I can combine them like this and I can call it 4.5, this yellow and blue. All right, and this red I can move it up and I can draw it like that. I can draw it like that. So this is the red, I know 2.6. all right, now I need to draw the resultant, and resultant is should be very easy. Resultant, let's use resultant. So this is my resultant. Okay, so how can I find the resultant? I know this one, I know that one, so resultant would be 2.6 squared plus 4.5 squared, and that would be 5.2. so resultant is 5.2. now I have to find the angle. How can I find the angle? Well, so we can use the we can get the angle from here. Let's see. So this is 30 degree. all right, so this is 30 degree, so this is 90 degree, and this is 60 degree. all right, so then what is the angle over here? So the angle over here is then 60 degree. all right, so we know the geometry gives us the resultant 5.2 meter and theta is also 60 degree. so geometry gives us the same answer like the trigonometry. Now I'm going to do a little different way, the second way of the geometry, by head and tail. So this is vector A. Vector A has two components. I'm going to make it the y component by red and x component by yellow. all right, so what I know about this angle now, this angle is 30 degree because this is 30 degree. so now this is 60 degree. so if I come over here, opposite to 90 is 2x, opposite to 60 is x root 3, and opposite to 30 is x. so the 1.5, then 1.5 is square root of 3 is 2.6, and x is 1.5. so it seems like the yellow one is, this is the yellow one, this is the yellow one is 2.6, so 2.6, and this is the red one, and red one is 1.5. all right, so now let's see how that will help us draw it. Okay, so now let's go ahead and draw it. This one, if we draw it, what do we get? 3 plus 1.5, 4.5, All right, okay, and the yellow one 1.5. okay, now this is the resultant. So 4.5, 1.5, okay, that 2.6, sorry, 2.6. So that's supposed to give us 4.5 squared plus 2.6 squared is 5.2. So this is 5.2, 60 degree. So 60 degree. All right, now I'm going to show you by law of cosine. So law of cosine. Law of cosine. So what is law of cosine? C squared is equal to a squared plus b squared minus 2ab cosine c, which is 3, and then we're going to draw vector a, which is also 3, okay, and then we're going to connect vector a and b, right? So this is the 3, this is 3, so this seems like an isosceles triangle. So let's draw an isosceles triangle. All right, so this is what we want to find. We're going to call it a small c. We're going to call this one a small c. All right, if this is a small c, this would be big C. This is big. This is, you're going to call it b. Let's say this is, you're going to call it big A. So this is a small a. This is big B. You're going to call it a small b. All right. So now we know this angle. What is this angle? This angle is, let's see. So this is 30 degree and this is 90 degree. So 30 and 90, 120. So this is 120. Okay, and this two angle has to be same because this is isosceles. So this is 30 and this is 30. Okay, so the law of cosine is c squared is a squared 3 squared plus b squared 3 squared minus 2 3 cosine 120. All right, so c squared is 9 plus 9 minus 18 5. So c squared is equal to 9 plus 9 plus 9. So c squared is equal to 27. So c is 5.2. So c is, now we finally found c, which is green, which is yellow. So c is 5.2. Now, all right, so we found the resultant using law of cosine, and we already know the angle is 60 degree. All right, very nice. Okay, good. Now we're gonna do law of sine. All right, so now let's manipulate it. So this is our x, this is our y. Now let's move using head and tail. Let's have the blue vector and let's move the green vector. All right, and this is the resultant. So basically we have what we have, isosceles with the blue, which is 3, with the green, which is also 3, with the yellow, which we need to find. So let's call this one A. Okay, A is the something we want to find, so then let's call it A. A is the angle. This is 120. Why it is 120? I explained it before why it is 120. So this is 120. Okay, this is then 30. This is then 30 because this is an isosceles triangle. Okay, good. Now we want to find A. Okay, so let's use this two ratio. Okay, so let's go ahead. Sine angles and sine angle. So sine 120 divided by a, we don't know, is equal to sine b. All right, so sine b, where is b? So let's put b over here and call it b. Let's put c over here and call it c. All right, so b is sine b, so sine b is 30, so sine 30, and sine 30 over b is 3. So we're going to do now cross multiplication. If we do cross multiplication, what do we get? A sine 30 is equal to 3 sine 120. So a is equal to, that's what we try to find, 3 sine 120 over sine 30. Alright, so 5.2. So a is 5.2. So law of cosine also give us the 5.2, and we also show this is 60 degree. Alright, now I'm going to show you by parallelogram the theta plus b square. Okay, so now let's use the parallelogram. Okay, so first we're going to draw x and y. Alright, so we're going to draw the vector a, okay, and we're going to draw the vector b. Now we're going to draw the parallelogram. So let's draw the vector b on top of vector a, and let's draw the vector a without changing the direction. Okay, so we have 3, 3, 3 and 3. So the resultant would be this one. All right, so let's see, if this is 30 degree, this one should be 60 degrees, is that right? Okay. All right, so now r square is equal to a square, which is 3 square plus 2 3 3 cosine, cosine is 60, plus b squared, which is 9. Okay, good. So r squared is equal to 9 plus 9. So r squared is 27, so r is 5.2. So the law of parallelogram give us the resultant, which is of course 5.2. So 5.2. All right, now we're gonna use the distance formula. So remind you, the distance formula would be, now this is distance formula. So d is equal to x2 minus x1 squared plus y2 minus y1 squared. All right, so now let's draw the vector 1. So this is incremented by, so each box is 0.1. Okay, so our first point, so we want to, this is our vector, this is our problem, this is x, this is y, this is vector a, which is 3, this is vector b, which is also 3. Now I need distance formula, I need x1, y1, x2, y2. So how can I get it? So quickly show you, vector, I have vector a and vector b. A has x1, y1, and b has x2, y2. x1, y1, this is 30 degree, if you still remember. So 3 cosine 30 would be 2.6. 3 sine 30 would be 1.5. 3 cosine 90 would be 0. 3 sine 90 would be 3. Okay, good. Now this is my x1, y1. So now I'm going to write x1 comma y1, which is 2.6 comma 1.5, and x2, y2 would be 0 comma 3. All right, good. Now I have 2 points. This is my vector A and this is my vector B. All right, so let's make the color, fix the color. This is vector B. So let's draw the vector A. Vector A 2.6 comma 1.5 this is my vector A. I'm not sure whether I can draw it. Okay, so this is my vector A. Now let's draw my vector B, 0 comma 3. So I know how to draw 0 comma 3. So 0 comma 3 is right here. Good. I draw both vector. Now I'm going to move this vector by using head and tail. All right, good. Now this is vector A, so I don't need 2 copies of vector A, so I'm going to erase this. All right, now distance formula allow me to draw the resultant. So the resultant is from origin, which is 0 comma 0, and if you count this is 2.6, and if you count this from here to here, 4.5. So I'm going to join them. So this is R. I have to find the R. So let's see. I have 2 points. This is x1, y1. This is x2, y2. All right. So distance is x2. So what is x2? x2 is 2.6 minus 0, x1 0 square, plus y2 4.5 minus minus y1 0. So d is equal to 5.2. So d is equal to 5.2, and we know that this is 60 degrees.